Welcome to this deep dive. Today we have a really fascinating stack of research to go through. Specifically an excerpt exploring the deep science of what our brains are actually doing when we, close our eyes at night.
Yeah, and our mission today is to investigate what is honestly a truly bizarre evolutionary paradox. I mean, it's wild when you really break it down.
It really is. Because think about it, you, the listener, once a day, you just deliberately lose consciousness. You lie down, you completely stop paying attention to your surroundings, and you spend roughly a third of your entire life.
Which is what, around 25 years if you make it to 75?
Exactly. 25 years, you spend all that time paralyzed, unaware, and just totally defenseless.
Mm.
So our goal today is to answer one profound question based on these sources. Why do we take this massive, potentially lethal risk every single night?
Right, because it is a massive gamble from a purely evolutionary standpoint. I mean, the vulnerability is so extreme that the biological payoff has to be equally immense.
It has to be worth it.
Exactly. Sleep isn't just some inconvenience or like a quirk of nature. The benefits it provides are entirely non-negotiable for our survival.
Okay, let's unpack this, because it really is practically evolutionary insanity.
It really is.
If you picture an animal out in the wild that is asleep, that animal cannot forage for food. You cannot watch for predators. You can't defend its territory, and it definitely can't find a mate.
Yeah, it is essentially sitting there as a free lunch.
Right. And knowing that natural selection is absolutely ruthless about waste and inefficiency, well, it would have stamped out something this costly millions of years ago unless it was doing something profoundly essential.
And that vulnerability, it forces us to rethink what sleep actually is. Because from the outside, it looks like a passive state. It feels like flipping a switch where the system just powers down for the night.
Right, like you're just off.
Yeah, but if we look at the internal neurobiology, the brain is far from idle. It's
Yeah.
actually cycling through a series of highly distinct stages over and over again all night long. Yeah, broadly speaking, the sources divide this into two very different kinds of sleep, happening in reliable, roughly 90-minute intervals.
Okay, so it's not a flat baseline of rest. If I'm trying to picture this, rather than thinking of sleep like flipping a light switch off, it seems a lot more like a washing machine.
Oh, that's a good way to look at it.
All right, you hit start, and it runs through these complex pre-programmed cycles. It's not just sitting idle full of water. It's doing a heavy wash, then a rinse, then a spin, and it repeats that sequence.
What's fascinating here is how structured that sequence actually is. So the first broad category is non-REM sleep.
And what does that mean exactly?
So it's a stage that deepens in steps until you reach the absolute deepest part, which is known as slow wave sleep. If you were to monitor the brain during this time, the chaotic, fast-paced electrical chatter of your waking hours, it just disappears.
It just goes away entirely.
Pretty much, yeah. It is replaced by these big, sweeping, synchronized electrical waves. So this slow wave stage is the incredibly hard-to-wake, deeply restorative sleep that dominates the early part of the night.
Okay, and that's distinct from the second category, right? Which is REM sleep.
Yes.
The sources define REM as rapid eye movement, where the eyes are actually flicking and darting around beneath closed lids. Which, honestly, that looks a bit chaotic from the outside. So how does that fit into a restorative process?
Well, REM is where the most vivid dreaming happens. It is a completely bizarre physiological state, honestly,
How so?
because your brain is buzzing with electrical activity almost identical to when you are wide awake.
Wait, really? The brain looks awake?
Yeah, exactly. Yet simultaneously, your body is deliberately paralyzed.
Whoa.
Yeah, your brain sends a chemical signal down your spinal cord to lock your voluntary muscles in place. The evolutionary reasoning is likely so that you don't, jump out of bed and physically act out those vivid dreams.
Because that could be disastrous. You could run into a wall or something.
Exactly. So you take this journey several times a night, right? Cycling between the deep, slow wave repair and the active REM dream state. And those REM cycles actually get longer as morning approaches.
Okay, so if the brain is cycling through these highly structured stages and actively firing chemical signals to paralyze your muscles, it's clearly doing some heavy lifting.
Very heavy.
What is it actually working on? Because looking at the research, the first major task seems to be managing the sheer volume of data you take in during the day.
Right. The primary mechanism we are looking at there is memory consolidation.
Okay.
Sleep is the active process where your brain takes fragile, freshly formed memories of what you experienced and physically files them into durable long-term storage.
How does that physically happen, though? Is it just transferring data from one place to another?
Anatomically, yes, it actually is. You can think of the hippocampus.
Like is where?
It's a structure deep in the brain. You can think of it as a temporary USB stick. It gathers information throughout the day, but it has limited storage.
Okay, that makes sense.
So during deep sleep, the brain replays the day's experiences, firing the exact same neural pathways that were active when you were learning. And through this replay, the hippocampus transfers that data to the cortex, which basically acts as the brain's permanent hard drive.
Oh, wow. So it's downloading the USB stick.
Exactly. It strengthens the connections worth keeping and actively deletes the trivial, unnecessary information.
That brings to mind like an office worker. The waking brain is like a stressed employee, frantically having loose papers thrown on their desk all day long.
Yes.
Like phone numbers, conversations, a new software process at work, what you ate for lunch. By 5 p.m., the desk is just a chaotic mountain of paper.
Right, a total mess.
So sleep is the night shift that comes in, looks at the pile, throws the lunch menu in the shredder, and meticulously files the important documents into the permanent filing cabinet so you can find them tomorrow.
And if that night shift never clocks in because you pulled an all-nighter, well, those papers just stay piled on the desk.
Oh, man.
This is why pulling an all-nighter to cram for a test or prep for a big presentation is just biologically counterproductive.
Because the night shift didn't show up.
Exactly. You stay up trying to stuff more facts into your short-term memory.
Adding more paper to the desk.
Right. Adding more paper. But the transfer to the hard drive never happens. The facts don't get properly stored. Studies consistently show that students who sleep after studying retain significantly more than those who stay awake to keep reading.
That is so important for people to realize.
Yeah, sleep is not a break from learning. It is the biological mechanism that makes learning permanent.
Okay, here's where it gets really interesting, because that covers the software, right, the data. But any machine running that much software is going to generate physical exhaust.
Absolutely.
We are also talking about biological hardware here, which brings us to a 2013 discovery in the sources about the brain's waste disposal system.
Right, so the brain is metabolically the busiest organ in the human body. And because it works so hard, it generates a massive amount of molecular waste in the tissue throughout the day.
Like cellular trash.
Yeah, cellular trash. In the rest of the body, the lymphatic system clears out cellular waste. But the brain doesn't have those conventional lymphatic vessels. So for a long time, researchers had no idea how the brain took out its trash.
So how does it clear out that exhaust if the plumbing isn't even there?
Well, the breakthrough in 2013 revealed a completely hidden system. Researchers discovered that during deep sleep, the brain's glial cells.
Glial cells, what are those?
They're basically the supportive cells surrounding the neurons. Well, they actually shrink in size during deep sleep.
The cells shrink.
Yeah, and by shrinking, they significantly widen the channels between the cells. And when those channels open up, cerebrospinal fluid,
The liquid in the brain.
right, the clear liquid that cushions your brain and spinal cord, it flushes through the tissue at a highly accelerated rate.
Wow, so the brain is literally bathing itself. Like, the brain is entirely bathed in that cerebrospinal fluid all the time. But during deep sleep, the channels widen, allowing that fluid to flush through like a fleet of street sweepers at 3 a.m.
That is a perfect analogy.
Because you couldn't possibly run those street sweepers during rush hour. The traffic of waking consciousness is just too heavy. The sweepers can only wash the grime into the gutters when the city is completely shut down.
Exactly. The brain runs this physical rinse cycle overnight to wash away the toxic metabolic byproducts of waking life.
That is incredible.
It is. It's an influential finding, though it is worth noting that the exact mechanisms are still being actively researched in humans, as much of the initial mapping was done in animal models.
Right. Science is always evolving.
Yeah, but if we tie this back to our opening paradox, like why evolution risks our lives to put us to sleep, this rinse cycle provides a powerful candidate.
Because it has to clean the hardware.
Right. The brain might require sleep because it is the only safe biological window to physically clean its own hardware.
Okay, so if the hardware is physically suffocating in its own metabolic waste without that rinse cycle, is that why we become completely emotionally unhinged after a bad night's sleep? I mean, I know I do.
Oh, there is a direct line between the two. Beyond the physical cleaning and cognitive filing, REM sleep specifically plays a massive role in emotional regulation.
Really? REM sleep does that.
Yeah, it processes difficult or traumatic experiences, effectively stripping the emotional sting away from the memory.
So you wake up feeling a bit better about whatever happened yesterday.
Exactly. Furthermore, sleep regulates critical hormones governing appetite and stress, and it bolsters immune function. So the downstream effects of interrupting this are immediate.
Which means the very next day, your attention, reaction time, and judgment measurably suffer.
Drastically.
In fact, the sources even compare drowsy driving to driving under the influence of alcohol.
The impairment levels are remarkably similar, actually. And looking at the long-term data, chronic poor sleep, like consistently cutting your rest short over years.
Which so many people do.
Which they do, yeah. It correlates strongly with higher risks of cardiovascular disease, metabolic issues like type 2 diabetes, weakened immunity, and severe mental health challenges.
Okay, wait, let me push back here. Wait, so I'm hearing these incredibly scary statistics about heart disease and car crashes, but you're telling me not to stress about it.
Mm-hmm.
Because the sources also explicitly warn against scaremongering.
Right.
How are you supposed to take this seriously without giving yourself massive sleep-preventing anxiety? Like, if a listener lies in bed thinking, if I don't fall asleep in 10 minutes, I'm damaging my heart, that anxiety is going to keep them awake indefinitely.
You're completely right to feel the friction there. The research can act as a double-edged sword. Long-term, the correlations with metabolic and heart diseases are undeniably real and backed by extensive data.
Okay.
However, the literature explicitly warns against the nocebo effect.
What's the nocebo effect?
It's where stressing about the negative consequences of not sleeping actively triggers cortisol and adrenaline. So by stressing about not sleeping, you are physically preventing yourself from sleeping.
Oh, that is a cruel irony.
It really is. Human sleep studies are complex, and much of the data is correlational rather than a simple cause and effect in a vacuum.
So how do we process the data without spiraling into panic?
The scientific consensus is to view sleep as a macro trend, not a nightly pass or fail test.
Ah, okay.
The goal is to treat sleep as a foundational pillar of health, exactly like diet and exercise.
That makes a lot of sense.
Right. If you eat a terrible meal or miss the gym for a week, you don't panic and assume your body is permanently destroyed.
Right, you just try to eat better the next day.
Exactly. You simply recalibrate and get back on track. Sleep requires that same steady respect, entirely free from panic.
So what does this all mean? If we aren't panicking, but we want to secure the cognitive filing and the physical rinse cycle, what does the science actually instruct us to do? Because looking at the sources, there doesn't seem to be a magical supplement or exotic biohack in the research.
No, not at all. The guidelines are entirely unglamorous, which usually confirms they are grounded in real biology.
Unfortunate, but true.
Yeah. Most adults require somewhere between 7 to 9 hours of sleep, though individual biological needs do vary. But the most critical factor the research points to is regularity.
Meaning going to bed and waking up at the exact same time.
Every single day.
Even on weekends.
Even on weekends. Your body operates on a circadian rhythm, which is a 24-hour internal clock dictating hormone release and cellular repair.
Okay.
And that rhythm depends heavily on behavioral consistency. Waking up at the same time on weekends as you do on weekdays keeps that internal clock synchronized with all the biological tasks it needs to perform.
Got it. And the sources also highlight light as the master signal for that circadian clock, right?
Absolutely.
So getting bright light in your eyes early in the morning starts the waking timer, and dimming the lights in the evening signals the brain to prepare for that slow wave descent we talked about.
Yes, light is crucial.
Which completely explains why staring at the bright blue glow of a phone or tablet late at night is so detrimental. I mean, it actively tricks the brain's light receptors into believing the sun is still up.
Exactly. And along with managing light, protecting the actual architecture of your sleep requires avoiding fragmenting factors.
Like caffeine.
Yeah, caffeine has a long half-life, and it physically blocks the chemical receptors that induce slow-wave sleep. But honestly, alcohol is perhaps the most misunderstood fragmenting factor.
Really? Because people rely on a nightcap to fall asleep all the time. They think it acts as a sedative.
Well, it does act as a sedative, meaning it might help you lose consciousness faster, but it is deeply disruptive to the biological cycles.
So,
Alcohol specifically fragments sleep quality, and it severely suppresses REM dream sleep.
the stage that processes emotions.
Exactly. So you may be unconscious, but you are effectively blocking the emotional processing and cognitive filing that the brain desperately needs to accomplish.
Wow. So if we connect this to the bigger picture, aligning our daily habits with our biology just gives the brain the runway it needs. Dimming the lights, keeping a schedule, skipping the late coffee or alcohol. It simply allows the machine to run its wash, rinse, and spin cycles without fighting against the environment we've imposed on it.
Right, we are just getting out of the brain's way. Let it do its job.
You know, the most powerful takeaway from all of this research, for me at least, is a total perspective shift.
In what way?
Well, we are so conditioned by modern culture to treat sleep as dead hours. We view it as time subtracted from living, like an annoying biological tax we have to pay so we can get back to work.
Oh, absolutely.
But the science proves the exact reverse. You aren't switched off at all. You are in the workshop.
I love that phrasing.
That third of your life you spend asleep is exactly what physically and cognitively builds the machinery that allows the other two-thirds to function properly.
Evolution decided that the workshop was worth being utterly defenseless for, night after night, for hundreds of millions of years.
That really puts it in perspective.
Yeah, that biological investment alone proves it isn't wasted time. It is the absolute foundation of human performance.
Which leaves a thought I really want you, the listener, to ponder tonight. If evolution deemed sleep so utterly essential that it was worth risking being eaten by predators for millions of years, how might our modern hyperproductive society need to fundamentally restructure itself?
It's a big question.
It is, because if we truly accepted sleep as the workshop rather than a biological inconvenience, how would we change our 9-to-5 work culture? How would we change the agonizingly early times our teenagers are forced to show up for high school?
Yeah, the school start times are a huge issue.
Right. If sleep is the literal workshop where our brains are built, cleaned, and maintained, maybe we need to stop treating it like a luxury we can just negotiate away. Well, thank you for joining us on this deep dive. Take this science, set a consistent alarm, dim those screens, and, thoroughly enjoy your brain's rinse cycle tonight. Good night.